Alright, so today we're going to start working on this indicator holder for an indicator stand. We're going to go over some of the order of operation on this. We're essentially going to get rid of these holes for the stem of an indicator, and we're just going to go with the clamp for the back plate. I did have it somewhere right here. So we're just going to have that slot there for the back plate of an indicator. This one is off of a cheap Chinesium indicator stand, but it was a reasonable price with the granite surface plate and everything. And I don't really use the stem holes here, so we're just gonna essentially eliminate that. As you can see here on the print, it's just got this slot, and it's got the through hole for the little bushing, and the thread over here for the thumb screw. But we are going to extend this out. Right now that's only like 3/4 of an inch or so. Yeah. About 8/64. And we're going to extend it out to a little over 1 3/4. I should have just made that 1 3/4, but I made it the full depth of this hole here, so that way you can extend it in and out instead of just having this groove here where this set screw locks into and holds it in place. But it also has no way of indexing it perfectly vertical. So I drew into the plan was this flat. You can see here it's 400 thousandths diameter for this hole, and this is 320 thousandths. So I'm taking 80 thou off the top of that round as a flat, so that it always indexes perfectly vertical. That way when we slide it in and out, it doesn't rotate any, get any kind of variation in the measurement. Is what we're doing with this. We have to have accuracy to the 10th, like no more than a 10th. So having it perfectly vertical is super important. But I went out and I could have just ordered some like 4140 or something to do this, but instead we're going to do it out of a piece of material you can find at really any hardware store. This is just a 1 inch by 8 inch grade 5 bolt. Now, if you're ever wondering what the grade of a bolt is, these little tick marks, usually it's 2 more than the number of tick marks that are perpendicular to the flat of the bolt. So this is 3. So it's a grade 5. If there's 6 of them, it's a grade 8. But it's a hardenable piece of steel. I can, if I want to, I can take it out to the forge and harden it real quick. But I think we're just going to leave it in the state that it's in currently, because that's plenty hard enough for our purposes. But first thing we're going to do is chuck this unthreaded shaft into the lathe and cut this head off, because we're really... What are you laughing about? I'm going to cut the head off? Is that what was funny? But my spindle bore on my lathe is only 1 inch, a little over 1 inch. So if we take the head off, I can chuck this shaft all the way into the spindle bore. And we're really only going to use probably about to here. This is a 1-to-1 drawing, so
Hey.
Actually check it. Yeah, we're only really going to use the threaded section, because the root of that thread is actually almost exactly the distance corner to corner on this part. So we'll cut that head off. We'll turn these threads down till they're right even with the root of the thread. We'll just turn them all the way off. And then we'll turn this diameter down to 0.4. And what we're going to do with that is we're going to chuck it into the dividing head on the mill. And we'll machine all these features here. We'll start with the square. And then we'll come in and machine this slot, which is this here. It's a 1/4 inch slot. And then we'll rotate it 90 degrees. We'll machine this relief out. That way it actually flexes a lot easier and clamps. And then I don't have a slitting saw, so what we'll do is just slit this with probably a hacksaw. That's not really a critical dimension there. That's just giving it a relief to be able to clamp. But we'll cut that almost all the way down to the round, that shoulder. And then so that we keep these features perfectly parallel or perfectly perpendicular to this flat, we'll put it in a regular vise on a parallel, and then machine this flat here on the shaft. That's the order of operations we're going to do. Probably in the next video we'll start working on getting this prepped to start machining all the features on this. We may actually also remake this bushing. I don't like how loose of a fit that is in there. It's all weeble wobbly and whatnot. I'd rather it be nearly a perfect slip fit in there. That way there's no bias on the back plate. It's not going to try and push it one way or the other. But yeah, that's what we're going to do with that. If I were to go out and buy a length of this material in actual 4140 or some other kind of hardenable steel, I'd probably be spending 40, 50, 60 bucks or 30 bucks with shipping, that kind of stuff. This is readily available at 5 different stores in my town. It's perfectly adequate steel, and it was only $8, I believe.
No, $51.
No, that was the big piece of metal.
Oh, this.
Don't mind the apprentice. He's misremembering stuff at the hardware store. But this was $8. We were looking at some other steel parts that were the $50, but it was $15 with the other stuff we bought.
Dad.
Yeah, we'll start taking care of all this on the next video. Thanks for watching, and enjoy your day.